In this video, we'll show you some of the ways that you can transform your data with the power of Hive and Spark using freely available nodes in KNIME Analytics platform. We'll demonstrate in-database ETL processing procedures on a Hive backend, and then show an approach for tackling these tasks using both Spark nodes and execution of Spark SQL queries. We'll also discuss Spark partitioning and briefly present the Spark Web UI, useful for monitoring your Spark jobs. To follow along with the workflows we'll build in this video, it will be helpful for you to install both the KNIME Big Data Connectors extension as well as the KNIME extension for Apache Spark. Ready? Let's get started. Let's consider an example where you need to connect to a dataset that exists on a distributed Hive cluster and extract a subset of transformed data. The dataset is much too large to handle on your local machine, so it's an absolute must that all computation be pushed down to the database for efficient operation. Is this something KNIME can handle? Absolutely. For remote connections to a Hive cluster, we could start by using a Hive connector node like the one shown here to make an initial connection to the cluster. In the configuration of the node, we would just need to provide the host name, database name, and appropriate credentials. I could set additional JDBC parameters in the JDBC Parameters tab. For this example, I'll instead use a local big data environment node to create a Hive instance on my laptop. Here, we'll read in publicly available data on European football matches that I've already loaded into Hive. To do this, I'll connect the local big data environment node to a couple of DB table selector nodes to choose two tables for my database. One containing records on individual events taking place during these games, for example, shots on goal and fouls, and the other listing times and descriptions of the events. I'd like to combine these results into a single record set, so I'll next use a DB joiner node and configure it to perform an inner join on the event ID. At this point, I have more columns in my data extract than I would like, so I'll use a DB column filter to remove some of them. Next, I'll count the events that exist in the dataset by their type. At this point, I can choose to write these results into a separate Hive table by using the DB connection table writer node. Finally, since the result of my aggregation is relatively small, I can pull it directly into KNIME using a DB reader node and create a bar chart to visualize my football events. It's important to note that if I were applying these database operations in a cloud environment, no data would be processed on my local machine until I explicitly requested a summary extract via the DB reader node. Prior to this, all computation would take place in the Hive cluster itself. I'm just using KNIME to visually govern the results of the analysis in a seamless way. Now that we've done a bit of ETL with KNIME's DB nodes on a Hive cluster, let's see what we can do with Spark instead. KNIME has a large number of dedicated Spark nodes to help you manipulate and transform your data. Everything from simple filtering, grouping, and pivoting to conversion between different distributed file formats like Parquet and ORC, and even advanced use of PySpark. Apart from extensive Spark ETL capabilities, KNIME also supports many of Spark's machine learning algorithms. To explore Spark in KNIME, let's continue our previous example on a different branch of our workflow, using Hive to Spark nodes to begin data processing. Let's connect two of these nodes to the DB table selector nodes as before. You'll notice that the square output ports have changed from a magenta color to black, indicating that we can now connect to Spark nodes downstream. Let's join our football events data as we did before, but this time using a Spark joiner node. We can use a Spark row filter node to choose just records associated with a particular team, in this case Real Madrid. Now, perhaps there's an operation that you would like to perform on your data by writing a SQL query. That's easy enough. Just use the Spark SQL query node to create a new first half, second half feature in our data set by applying a simple mathematical function like this. To summarize our data extract, let's connect a Spark pivoting node to aggregate events by player for each half and look at the results. Finally, we can write our results to a new table on our cluster using a Spark to Parquet node. We could also write to ORC or back to Hive if preferred. Note that throughout this process, Spark is performing lazy evaluation. That is, Spark does not apply the transformations until the data is actually needed, that is, when it's written to the file system. This can sometimes cause the node that triggers the evaluation to run longer than expected, because all the previous transformations are done in this step as well. Also worth noting is that Spark handles data in partitions. Usually a data frame, or RDD, is split into several partitions and distributed on the worker nodes in the cluster. This is done to parallelize the execution and avoid network traffic. Due to the distributed storage, data in a Hadoop cluster is spread to several worker nodes. Spark tries to process the data on nodes that are close to the data and only transfers them to other nodes if needed. Note that if you would like to adjust the Spark partitions yourself, you can do so using our partitioned by statement in a DB table creator node. Now that we've loaded and processed our data, we can take a look at the Spark web UI within KNIME to see what's going on behind the scenes and monitor the progress of our operations. By right-clicking on the Create Local Big Data Environment node and selecting Spark Context, like this, KNIME displays a window showing the options we used when executing the node. It also contains a blue hyperlink to open the Spark web UI. Let's do that now. When we do, we can see that we have access to a number of different summaries of Spark operations that have been performed, including a summary of complete jobs and their associated timeline, along with stages for the jobs, environment properties, and even specific SQL queries that have run, along with their elapsed times of execution. In this video, we've showed you how you can use KNIME to orchestrate many different types of ETL functions in both Hive and Spark, with a focus on pushing resource-intensive processing to your cluster. KNIME provides you with a convenient visual representation of your workflow, while still bringing to bear the full computational capabilities of your cluster on your big data environment.